Hello friends, how are you? In this video, we'll discuss about the exception and exception handling in Python. Okay, so first of all, we should know different types of errors. There are three types of error: syntax error, logical errors, and runtime errors. So what is a syntax error? Now, before that, what we should know what is syntax. So syntax is a set of rules and procedures that determines the constructions of a sentences in linguistic. So in linguistic, syntax is what? Some set of rules and procedure we should follow to construct a sentence. Suppose what is syntax? It's a sentence. So can you write like this way? Is what syntax? Can you write like this way? No, we cannot write like this way. So this is not sentence since we are not follow any rules. Okay, so there is a set of rules we have to follow to make the to construct a sentence. Similarly, in programming, we have to follow some rules. The rules specify the correct combinations of symbols and commands that make up a working program in a given language. It defines what is an acceptable string of text for a language. So, like linguistic in programming also, to write a program, we have to follow some rules. Okay, so that the program or interpreter can understand. Okay, if we do not follow this, then syntax error will appear. Okay, so what is syntax error? We have to see what is syntax error. So syntax error is what? The errors due to invalid syntax are called syntax errors. Or in other words, if we do not follow the rules defined by the programming language, we will get or we will receive syntax errors. So we have to follow the rules. If you do not follow the rules, we will receive syntax errors. It is the responsibility of the programmer to remedy this syntax problem. So see, the interpreter or compiler just identify the syntax. It is our responsibility to remove those syntax. Okay, so a program will execute only after rectification of all the syntax errors. So a program is there. Suppose here few problems are there. The programmer or interpreter, the compiler or the translator identify the problems. It is our responsibility to remove those syntax errors. And after that, the whole program will execute properly. Okay. Now we can see example of syntax error. We can see here A is equal to 7. Any problem is there here? Okay. So if you execute it, we can get the output. The value of A is 7. So no problem is there. Okay. Now another sentence is there. B space 8. Is it okay? Can you write this like this way? So if you do this one, we will receive an syntax error. Okay, it's an invalid sentence and it says where the problem is there. The problem is line number 4. We can see here in line number 4. So here it identify in which line the problem is there. Line number 4 problem is there. Okay, it's an invalid sentence. Are you getting this one? Now similarly, suppose if you execute this one, can you identify the error? If you execute it, we can get another. Okay, so we have to remove this one and we have to execute this one. So yeah, there's problem is there. In which line the problem is there? In line number 6, the problem is there. Okay, so in line number 6, the problem is there. Here the problem is in this particular part. So this is what syntax error. It's an invalid syntax. So we have to rectify it. After that, we can execute it properly. So we can see here. So what you can do? We have to use double quote inside this, and if you execute it, then and only we can get the output. Okay, so it's clear. So this is nothing but our syntax error. So the interpreter or the compiler identify the lines where the problem is there. It is our responsibility to remove those errors. Okay, next we'll go for the logical errors. So in logical error is also called bugs. It's a very difficult to identify and it's very difficult to remove. A logical error occurs when program's logic is incorrect. Okay, syntax is okay, everything is okay, but the actual logic is not correct, then definitely will not get our desired result. So the program completes its execution, but it does not perform as planned. Okay, the program completes its execution, but as per our requirement, will not get any or will not get proper output. So generally the problem is like this. So it should be x greater than equal to 5, and we have written x is equal to 5. Okay, sometimes we may use some infinite loop. Okay, or sometimes we use the problem like this way. Say, can you identify the difference between these three? So this is what 5. This is nothing but a 5 by 6 into 7. Okay, now this one is different. This one is what 5 by 6 into 7. Okay, and this one is same as this one. So we have to specify which one we want. Okay, so similarly, if a is equal to a is equal to 10, after a few lines, we lines use same variable as a is equal to 14. Now suppose a line is there, and here every time the value of a should be 10. Okay, here 10, here 10, but somehow here in this particular part of the program, we have accidentally changed the value. So here the value of a will be what 14. So it's a logical error. Okay, so the computer, the computer or the programming language or say compiler does not identify the problem. It is our responsibility to check our program. Okay. Now we can see one example of logical error. A concrete example of logical error. So addition of first three number starting from 2. So starting from 2, first three number means what? 2, 3 and 4. So 4 plus 3, 7, 7 plus 2, 9. So output will be what? Output will be 9. So starting from 2. So we have written two programs here using for loop and using while loop. Okay, so here you just see this one, sum is equal to 0 for I in range 2 comma 4. Sum plus I is equal to the result one is sum. Okay, so sum is equal to 0 means initially the value of the sum is equal to 0. Then I is in 2 to 4. So I is in 2, 3 and 4. Okay, so sum is equal to sum plus I. So initially sum, so actually 2 to 4, the output is what? What will be the output? So if you execute it, yeah, is the output 5? Okay, so you can see here, output is not 5. You can see here output is not 9, output is 5. How it is so? Any problem is there? See, we are getting output. Okay, the program is executing properly. Yes, but the output is not 5. It is not 9, it is 5. Okay, so there is a problem. So what do we have to do? So we have to do something different. Okay, so some problem is there, some logical problem is there. So do you know what is the logical problem here? So initially I is equal to range 2 to 4. So 2 to 4 means what? 2 and 3. So initially it is sum is equal to sum plus I, it is 2. Then once again, next time it is 3. So 3 plus 2, it is equal to 5. So what we have to do? We have to change like this way. So instead of 4, it should be 5. Okay. And if you execute it, we can get proper output 9. So here we have instead of 4, it should be 5. Are you getting there? Achha. Similarly, in this case, in this particular problem, is there any problem is there? Okay, here the output is what? You can see here, output is 7. It is also not 9. So you can check, initially sum is equal to 0. Sum is equal to 0. Then why I less than equal to 4? What is I? I is equal to 2. Condition is I is equal to 2. Condition is true. Increment I. The value of I is equal to what? Now it is 3. Sum is equal to sum plus I. So that means sum should be what? It is 3. Okay, then I the value of present value of I is what? It is 3. 3 is less than 4. Yes, increment 3. Now the value of I is equal to what? 4. Sum I. Sum I. That means 4 plus 3. What is it? Is 7. Once again, it will check I is less than equal to 4. No, condition is false. Then come out from the loop and the output is sum. Here the problem is it starts from 3. It doesn't start from 2. It is not starting from 2. Okay, it starts from 3. So what we have to do? We have to change the sequence. We can see here. Here we have to put here. Means here we have to write I plus is equal to 1. And if you execute it now, it is also not 9. It is a 5. Okay, we can see what is the problem. The sum is equal to 0. No issue. I is equal to 2. Starting is equal to what? It is a 2. Then 2 is less than 4, yes. Increment sum. Now sum is 2. Increment I. Now the value of I is 3. The 3 is less than 4. Condition true. Addition of sum. So 3 plus 2, it is 5. Increment I. Now it is 4. Now 4 is less than 4. Yeah. Condition is false. Come out from the loop. So the final answer is 5. So we have to do something different. Do you know what we have to do? Here we have to change the program. Here we have to write less than equal to 4. And if you execute it, we can get the correct answer. So here logical errors are there. So instead of less than, we have to write less than equal to. Then we can get proper output. Are you getting there? This is an example of logical error. Next, third error is what? Runtime error. It is also called exception. So what is that? While executing a program, runtime errors may occur due to something as follows. It may be the end user input. It may be the programming language. It may be the memory problem. End user input means suppose we want to accept integer value, but we provide the character. We provide character. Then this is called end user input problem. Programming logic. Suppose we have identified a division 5 by 0. That's a logic we are using, which is dangerous logic. Next, memory problem. Suppose one file is there and we want to read the content of the file. Now, if we reach the last line, if you reach the last character, definitely there is a problem. There must be a problem. We have to halt there. So that problem is called memory problem. Or suppose one variable is there and it can store only 20 digits and we want to store 21 digits. Definitely we cannot store 21 digits if the capacity is to hold 20 digits. Okay, so that is called memory problem. So while executing a program, runtime errors may occur due to some reasons and we have to handle it properly. So these are called runtime errors or called exception. Now we can see the example. Now we can see here the output is 9 by 0. 9 by 0. Then, and if you execute it, we can get the output. Here the output is what? Output is 0 division error. It identifies the lines in line number 2. Okay, so 0 division error, it is the exception name. So 0 division error is exception name and it is a message related to the exception. Division by 0. Are you getting there? So we have to rectify this particular line to solve it. Are you getting this one? Now we can see here. If you execute both the lines, suppose here it is 9 by 2, and if you execute it, the output is 9 by 2 is what? 4.5, and it will execute the next line. It is the last statement. It is the last statement. But if it is a 9 by 0, and if you execute it, we can get the divide by 0 error, and it will not execute the rest of the program. So it will not execute the rest of the program. So it will halt abruptly. So it will halt the program. Similarly, we can see the another example. Suppose here you can see the output here z is equal to 8 into a. Okay, so 8 is a character and 8 is a integer and a is a character. So can we receive any error if you execute it? No, there is no problem. We can do it. So here no error, will not receive any error. So instead of 8, if it is a 4, we can get 4 errors. So this is not at all a syntax error or the runtime error. Okay, but if you write like this way, can you add character and the integer? Can you add character and integer? So if you execute it, we can get another error that is called type error. It is the exception name is what type error, and it is a message of that particular exception. So unsupported operand types is for plus integer and string. So we cannot add integer and characters. Okay, so the problem is at line number 8. You can see the problem is here. Okay, so we have to, so the exception identifies the problem. We have to rectify the problem. Is it okay? So what is exception? An exception is an unwelcome or unexpected event that disrupts the usual flow of a program. We can see this is what our unusual or unexpected event. So it will not execute further. Okay, if the problem is there, see, if the problem is not there, then no problem. If the problem is not there, then there is a no problem. Is we can get all the 4 lines. So instead of 0, if it is 2, and if you execute it, we can get all the 3 lines. Okay, but if it is 0, it will not. See, if it is a 0, the problem is definitely the problem is here. Here the problem is there. Okay, definitely the problem is there. So it will halt here. It will not execute this line as well as that line. Okay, so you have to take care for that. So different types of exceptions are there. We can see almost 30 different types of exceptions are there. We can see uh, so, so end of error, end of file error. So it's exception. The name of the exception is what? EOF error, end of file error. When the input function hits the end of file condition, it will raise end of file error. Similarly, floating point error. When a floating point operation fails, a floating point error exception will raise. Import error when the imported module is not found. Suppose we want to import a module which is not present, definitely it will give the import error. Similarly, overflow error when the result of the arithmetic operation is too large. It can't accommodate into that particular variable. It will raise overflow error, and so you just Google one by one and we can check the type 1, and if it is okay for you, you can in a description box you can give example of any one of that particular exception. That will be helpful for the other viewers. Okay, so different types of exceptions that there you can check. I will upload in a GitHub. You can check one by one. Okay, so exceptional handling to handle runtime error. So why should we apply exception, or why should we implement exceptional handling to handle runtime errors? Okay, so exceptional handling is strongly recommended. It's strongly recommended. The basic goal of exceptional handling is to graceful program termination, so that we should not block our resources or we should not miss anything. Okay, so suppose one program is there, if exception is there, so it will suddenly stop here. It will stop here only. It will not execute further. But if you execute exception, what will happen? If you receive exception error here or runtime error here, it will uh, uh, it will message something. It gives some indication, and it will print it, or it will execute the rest of the program if possible. Okay, so in exception handling, we do not remove exceptions. Actually, in exception handling, we do not remove any exception. We identify the exceptions and we give indications to the programmer, or we receive indications that the problem is there. We have to rectify it. Define alternative way to continue remaining part of the program normally. So if the problem, suppose one exception is there, and that will affect only this particular part of the program. So it will not execute that part, it will execute the remaining part. Okay, but if you do not use exceptional handling, it will not execute further, it will stop here. The whole program will affect. Okay, so types of exceptional handling: default exceptional handling and customized exception handling. Customized means what? We can use as per our requirement. So in Python, every exception is an object and classes are available for every exception. So basically, every exception is an object and associated classes are there. Whenever an exception occurs, Python virtual machine builds an exception object and look for action coding for handling it. If no handling code exists, then Python interpreter will stop the Python program abnormally and exceptional details are reported to the console. Okay, so we can see here, if you execute this one, suppose one problem is there, and if you execute this one, then what will happen? We receive an error that is called zero division error. So if you see this particular program, here the program of the value of I is equal to what? It will be 0, 1 and 2. And here it is what? First line will be what? 0 plus 1 by 0. So the division error is there. It will not execute for 1 and 2. So it abruptly, abnormally, and it will stop. Okay, interpreter will stop the Python program abnormally. And exceptional details are reported. This is what our exceptional details. So the name of this exception is what? Zero division error. And here it is, division by 0 is there. Are you getting this one? So we can use if else also. Suppose if you write like this way, if I not equal to 0, then execute this one. And if you execute this one, we do not receive any exception, because you are handling using some if conditions. But sometimes it is very difficult to identify the output or possible outcomes. So sometimes in that case, we have to use some exceptions. Okay, is it okay? So this is what our exceptions. Now we can see exceptional hierarchy of Python. So here, base exception is the root class. Okay, under this base exception, subclasses are exception, system exist, generator exist, and keyboard interrupt. Okay, and under this exception class, the subclasses are, these are the errors. These are what? The errors. Attribute errors, arithmetic errors, end of files errors, name, these are all the exceptions. Under this arithmetic exception, arithmetic error, floating point error, zero division error, and overflow errors are there. Similarly, under this lookup key error and index error are there. Similarly, inside the OS class, the subclasses are what? Timeout error, file not found error, interrupted error, and permission error. So this is what our whole hierarchy of the exception. Next, we discuss our main thing is what? Customized exception. Okay, using try and except. Okay, this is our actual objective of this particular video, to explain this one properly. Customized exceptional handling. Okay, the syntax is very easy. The syntax is what? What is the syntax? We have to use try and associated except. So we have to use try, and here associated corresponding except must be there. Here we have to write some codes. Here we may specify the exception name. We can specify the exception name. And then we have to mention what to do if exception will raise. It is called handling code or alternative code. So if exception name is there, it's okay. If it is not there, then we can use default exception. That we'll discuss. So try and except. Here we have to put our hazardous code or risky code or dangerous code. And if anything will occur, if anything uneven will occur, then we'll enter into the exception. And here we can take necessary actions. Okay. Next is what example of exception handling. We can see one example. So try. So try. The result is 10 by 0. Definitely, it's a risky code. Okay. And it will, if it tries there, associated except must be there. And definitely, we will receive zero division error. This is what name of the exception. So if the name of the, if it satisfy this one, if it is okay. So if the exception is zero division error, it will print the divide by zero is occurred. So this is nothing but our handling code. So if it is our risky code, it will be our handling code. Okay. So we can see here, you can see here, here we can see if you execute it, so definitely divide by zero is occurred and it is the last statement. Definitely here the problem will occur. Okay, and exception will got it, execute this particular part, and here the it prints divide by zero is occurred, divide by zero is, and finally it terminates properly. It will execute the remaining part of the program. Here the message, it is the last statement. It will execute. It will execute the last statement. Okay. So here in try, we just mention our hazardous statement. Here divide by zero will occur, is occurring. So that's why except will raise, and the name of exception is zero division error, and it will print that particular part. And after that, it will print the rest of the program. And if it is okay, if the program is correct, so if 10 by 3, then definitely no problem is there. So it will execute the output. The output will be what? The result is 3.33. After that, no exception will erase, and output will be what? It is the last statement. Okay, this one, okay. So if you do not use exception, and if you execute it, definitely will get right this way, this type of message. Okay, and it will not execute the rest of the program. You can see here, it is the last statement is not there. Are you getting there? That's why we have to write our program in such a way that we can handle such type of situations properly. So only hazardous code, you can see only hazardous code should be included in the try block, and the try block should be as short as possible, since if anywhere exception is raised, then rest of the try block will not be executed. So what is that? We can see here, we can see the meaning of that particular code, line of the line. We can see here inside the try block, one output is there, 10 by 0. Definitely problem is there, it's a risky code. But two non-risky codes are also there. It is the second statement, it is the third statement. Okay, and this is our final statement. Now if you execute it, divide by 0 is occurred. Divide by 0 is that if the problem is occurred, directly if the problem will occur, it will not execute rest of the try. It will directly jump to the except, it will print a divide by 0 error, and it will print it is the last statement. Okay, so our objective should be what? Keep the try block as simple as possible, as small as possible. So what you can do, we can keep these two lines outside of this particular try and except. Okay, our goal should be, we have to put those sentences after that. Okay, so we can see here, copy these two, okay, and paste here. Okay, and paste here, and what you can do, you can do like this. So if you execute it, now you can see here the problem is there, no problem, but still you can execute these two lines. Okay, so since unnecessary, we increase the size of the try block, so it will be better, we should not include those lines which are not at all risky. We should keep those lines, non-risky line, outside of the try. Okay, are you getting this one? So we just this one. Now, if you will not receive any problem, though definitely you can get the answer. And now one more thing is there. We may receive the problem inside the exception also. Okay, so inside the exception, the problem may also occur. So if you execute it, So we can see here uh, print exception is not occurred. So instead of definitely, if you put 0 here, then we will receive an error. You can see here. Okay, so there's a problem. It enters into the except. It will print the then it will receive this one. Okay, so it will print this particular part, divide by 0 is occurred, this one, and due to this particular line we will receive exception. Okay, at line number this one. So definitely exception, the runtime error may occur anywhere in the program. It may be inside the try, or it may be possible inside the except. Are you getting my point? So this is what our Acha. Display expression information. We can display the information of the exception also, like this way. Say, try input hero. One name of the module say hero. We don't know whether hero module is there or not. And here definitely if the hero module is not there, it will raise the import error. So if you write like this way, except import error msg, then import where import error, from import error inside this msg we can get the message from that particular message for the exception. So the message is what? No module name hero. Okay, so instead of msg we can write anything. Suppose if it is ac, and if you print the ac, we can get the same output. Exception due to AC. AC means what? In AC, no module name hero is there. So we can store the message inside this particular, inside any variable, using like this way. So import error is what? This is what? Name of the exception. Okay. So in this way we display the exception information. Next, try with multiple excepts. Okay. So we have seen that inside one try there is one except. So not only one except, we can add as many except as possible. As many except as possible we can add. So we can see the example here. So we just see the example properly. So here it should be values. Okay, we can save it. Acha. So first of all, you just see the program properly. Okay. So here try is there. Inside this try, import hero. Two we are inputting two input variables x and y using keyboard, and print the result is x by y. Okay, and here input hero is, once again input hero is there. So three exceptions are there. This exception will raise if import error is there. This exception will occur if zero division error will occur. If any problem is there inside this x and y, then this value error will occur. Suppose here that if import hero is not there, that hero module is not there, so it will execute, it will accept, will raise this particular exception. Okay, if any problem is there, it will raise this particular exception. If any problem is there inside this input, it will raise this particular exception. Okay, so we can see example. We can, if you execute it. Now, if you execute it, so enter the x value. Suppose it is 3. Enter the y value 4, and if you execute it, we can get module. The result is 0.75. The result is 3 by 4. No problem. But here hero module is not there. That's why it executes this particular exception. Value error. Sorry, it will execute module is not available. This one, because hero is not there. Are you getting my point? Now, once again we want to execute it. Now suppose we insert R here. It's not integer value. Character values are not accepted. You can see here. Here we have entered R. So directly it will jumps to this particular, this one, value error. It will not execute the rest of the part of the try. Okay. Now, suppose we have entered here this particular, if try to execute, say 4, then say 0. You can see second number must be non-zero. That means what? First x is what? X is, here it is 4, y is equal to 0. Here divide by 0, 0 division error will occur. So it will execute this particular part of the program. And it will print second number must be non-zero. You can see here, second number must be non-zero. Are you getting this one? So we can change it instead of here. If it is somewhere here, we can get the same set of. Suppose if you execute it, so definitely module is not available. So import hero. The error is there. It will not execute this particular part, and it will execute only this one. Module is not available. Achha. Can you change the position? Can you get the same output? So you can set here, and if you can execute it, can you get the same output? Yeah, we receive the same output. That means if we can change the position, the order is not important. Okay, but here the order is important. So it will be better. Try to accommodate maximum risky last, or if you write like this way, maximum risky code must be here, and less risky code must be in the beginning of the try. Okay, so maximum risky code should be at the beginning of the end of the try, and just before the end of this particular try, and low risky code must be at the beginning of the try, must be present at the beginning of the try. Okay, so that position is very important. So if you put here, instead of here, if you put here, then we can execute this particular part properly. Achha, handle multiple exception using single except block. Now here you can see 3 different errors are there, and for 3 different errors we mention 3 except. So can you mention one except, and can we put all the errors inside the same except? So in that case, we can see here, inside the except, we can put all the exceptions with message and without message, with message or without message. We can see the same problem. X, the input, enter the value of X, enter the value of Y. The result is X by Y. Input here, hero. And here we mention, inside this mention, except we mention all the errors. And we need the message also. So please check the try block for what? Okay, so if you execute it, we can see the output. So if you execute it, we can see the output. If you can execute it, where is that? This one. And if you can execute it, input is what? Say 3, enter it. Another input is say 2. The output is 1.5. Definitely import hero module is not there. Definitely it will execute this one, import error, and associated message. So please check the try block for, what? No module name hero. Are you getting my point? One second, I am executing this one. Suppose I have written P. Definitely, please check the try block for what? The problem is what? Value error. Are you getting this one? Once again, so if it is 8, enter 0, enter. Now division by 0. Error is there. Because the value of y is what? It is a 0. Okay, so inside a single except, we can accommodate all the exceptions. And we can get the message too. Okay. Next is default except what. Sometimes we do not know the type of exception. Sometimes we do not know what type of exception will raise. In that case, we should not mention any name of the exception. So if you do not mention the name of the exception, if you put except then colon, then it is called default except block. So try is there. The output is what? 7 by 2 import hero except. Please check the try block. So here not mentioning any exception name. So hence it is called default exception. So we can execute it and we can get the output that please check the try block because of this import hero. Okay. Now if you disable it and if you put 0 here and if you re-execute it, we can get the same output. Please check the try block because a problem is there. Okay. So if no problem is there, okay, then it will not print anything. Okay, so definite, sorry, it will print the output is this one. It will print this one. Okay, so it will not print. Please check the try log because no problem is there. Nothing is there. But if you put instead of 3, if it is 0, it will print. Please check the try log. Okay, so this is called default except block. So in default except block, we do not mention any exception name. Acha. Can you put default exception inside the exception with name? Now you can see here, try, input for X, input for Y, print the result and import hero. Except here we mention two types of exception error, zero division error and value error for these two errors, for these two input. And for import hero, we do not mention anything and we try to accommodate inside the except. Okay, so what you can do, suppose we want to execute it. Now suppose it is 4, okay, and it is say 2. So just it print the result is this one. No error is there. It will not execute any exception. But if the problem is there, suppose here it is say U, definitely problem is there. So it will print the please check the try block for the message. Similarly, we can put say 9, 0. Then definitely division by 0 is there. So it will execute this particular part. Now, suppose we may enable the import hero and we enter some valid number, say 9, 2. Now the result is 4.5. It is okay. But due to this line, because hero module is not there and it will not, that we do not mention any exception in this particular font. That's why it will execute this particular part. Something is going wrong. Okay, are you getting this one? Achha, remember one thing, that default except must be the last exception. We cannot put here. Suppose, can you put here exception? Can you put here? Can you execute it? Okay, we will receive a syntax error because default exception must be the last. Are you getting my point? So we cannot put exception like this. So default exception must be the last. If you execute, re-execute it, then no problem. Is it okay? Next, finally block. Finally block is what? Suppose you can see the finally block will be executed no matter if the try block raises an exception or not. Suppose if any problem is there, it will execute the except part as well as the finally block. If no problem is there, it will not execute the exception part, but it will still execute the finally part. So any code is there, we must execute whether the exception will raise or not. We have to put all this in finally block. Are you getting my point? Okay. So if try is there, if exception will occur, if say an error is occur, if error will occur, it will print the finally. If error is there, it will execute the exception. Okay, and then it will print the finally. If no error is there, still it will execute the finally and then stop the process. Are you getting my point? So if try block is there. If any error will occur, suppose one error is there. If any error will occur, if yes, then it will execute the exception part, except part. Then it will execute the finally part. But still no error is there, it will execute the finally part. And then you can stop output. Are you getting this one? So you can see here. So if the input is value, suppose you want to execute this one. So if the assume input is say 4 and here it is 2, so the result is what? The result is 4 by 3 by 4. Sorry, 4 by 3. It is 1.33, and it will execute. Now you can see here. Input is what? X is equal to 4 and Y is equal to 3. So 4 by 3 is what? It is 1.33. Okay, no error is there, but still it will give the output. All is going good. All is going good. Okay, now if you execute once again with some errors, suppose 5 and 0. Okay, so it's a division by error is there. Division by 0, that means what? This exception will echo. Please check the try block for something. But finally we'll get the output. All is going good also. So still we are executing this one. So this is called our finally block. Okay. Now nested try and except block. Okay. So we can see here inside a try and except we can mention another try and except. So one try is there. If error is there, if any error is there, if error is there, then it will print the except part, outer except part, and then it will execute the end. Suppose this one is the end. It will enter into some code. So finally, if no error is there, it will once again enter into the try and it will check the error. If no error is there, then it will enter into the finally. If error is there, it will enter into the another exception. And finally, it will enter into the this one. So if error is there, it will jump this particular part, it will ignore this particular part, and it will execute like this way in this part. If no error is there, first it will check the try. Then if error is there, then it will check this path. And if no error is there, in that case, it will go move like this way. So this is what our nested try block. Inside try, another try is there. Then it is called nested try block. So we can see the example. Here. This is our first try. Associated except is this one. Associated final is this one. Okay. We can see here inside this try, another try is there. Associated except is this one. Another associated final is this one. So if it is okay, so outer try, is it okay? Yes, it is okay. It will print this one. It will enter into it will execute the rest of the part. Inner try 9 by 7, is it okay? It will print this line also. So it will not execute this particular part because no problem is there. It will print the inner finally, third line. Since there is no problem, it will not print this particular part. It will print the finally fourth line. Okay. So if you execute it, you can see here. If you execute it, you can get the output here. Okay. So this is what our outer try, first line, inner try, second line, inner finally, third line, outer finally, fourth line. Okay. Now, if the problem is here, 7 by 0 is there, then what will happen? Do you know? So it will not execute this part. It will not execute further. It will execute outer except and finally. So only these two lines will execute. So we can execute it and we can get the output. You can see here only two lines will be executing. So outer except, we can see the first line, it is outer except, second line outer finally. Okay. Now if no nothing is there, but problem is here in this case. So do you know the number of lines it will execute? Please pause the video and write yourself and tell me the answer. In the description box, give you answer. So here it will print this particular line. It will not print this particular line. It will print this exception part, inner exception, except it will print this particular line. It will print this particular line. Since no problem is there inside this, it will not print this particular part. It will print this particular part, fourth line. Okay, we can see, we can execute it. We can see outer try, first the output outer try is there, inner except is there, inner finally is there, outer finally is there. Okay, so this is what our example of nested try and except. Achha. Next is the else with try except finally. You can see here, first try is there, you can say try is there. If any error is there, you can see here, if any error is there, if any error is there, it will execute the except part. If no error is there, it will execute the else part. And finally, it will execute the finally part. And then we can stop if it is required. Is it okay? So try, risky code is there. If any error is there, yes, it will execute the except part. It will execute the except part and then finally part. If no error is there, okay, you can take another color. If no error is there, if there is no error is there, so it will execute this particular part as well as else part. Error, no error is there, else part as well as the finally part. Okay, so except will be executed if exception is there inside the try. If exception is there, yes, it will execute the except part. When to execute else part, will be executed if there is no exception inside the try. Error is there, exception is there, no, it will execute the else part. So we can see the example. Okay, now here we can see the example. Print the division is 10 by 3. So no problem is there. So it will execute this line, it will execute this line, and it will execute this line. Okay, now execute it. You can see here, no problem is there. It will execute this one, the division is, then it will execute the else part and printing finally this one. Similarly, but if any error is there, suppose here it is division by 0 error is there. So suppose it is 0, then what will happen? It will print the except part as well as this part. It will not print else part and this one. You can check if you execute it. You can see here it is printing, exception is happening and printing finally. Okay, is it okay? Else part. Achha, question is, can we this particular sequence is very important. First try, then accept, then else, then finally. Okay, we cannot resequence this. We cannot rearrange it. Suppose, can you remove finally? Yeah, exception is handing. Yeah, we can remove it. So suppose instead of it is the correct answer, then also it is working. So no problem. So can we put else part before the exception, except part? before else part, can you put else part? No, we cannot put syntax error, invalid syntax. We cannot put else part before the except part. Are you getting my point? So we have to maintain the part. So can you put finally before else part? Can you put finally before the else part? No, we cannot. So we have to maintain the sequence, required sequence. Otherwise, it will not execute. So note that combination of try, except, else, finally is also important. That combination is important. We cannot change it. So we can see here, we can see whether it's a valid or not. So try and accept. If it is try and then accept, it's a valid one. Try, accept, accept. It is okay. No problem. We have seen. Try, accept, finally. Absolutely okay. Try, accept, else without finally. It is also acceptable. Try, accept, else, finally. Definitely it is acceptable. Try, accept, try, accept. Definitely is also acceptable. So some more combinations are there which are valid combinations. But I have mentioned, I have included only this. Try else. It is not valid. Okay, because exception is not there. Else finally, it is not valid because try is also not there. Try else else, it is not valid. There must be only single else. Try else except, it is also not valid. Some more not valid steps are there. Please check yourself, try yourself, and in the description box you can mention the others non-valid or valid combinations. Next is there with and as. Next is there with and as. In Python, the with statement is used for exceptional handling with clearer code and easier to comprehend. Okay, so we can see first of all, you just see these two programs. Okay, so we can see here. Here in this particular program, this is one part, this is another part. In this particular part, we have used my file one is there, and here we write something. Whoever is happy will make others happy too. And if it is not written properly, then it will exception will occur, and then it's the finally is there. Definitely it will print not properly written. Instead of finally, can you put except? I think you should put except here. We should put except here instead of finally. Okay, and we can save it. So we can execute it. So we can see here. Uh, we can execute it, and here two files are there. My file one, in this case, my file one. We are doing same thing here for my file two with open as file, and life is a long lesson in humility. So we are executing this one. So we can see here we are doing the same thing, and we are getting two files, my file one, and the output is what? Whoever is happy will make others happy too. And the second file is what? Life is a long lesson in humility. Okay, so we are doing the same thing here. We need 4 lines to execute, but here only need 2 lines. Are you getting? No, here we need 5 lines. We have to include this one also, but here we need only 2 lines. Okay. Next, types of exceptions. Definitely predefined exception and user defined exceptions. Okay, so these are what predefined exceptions. Divide by 0. Okay, are you getting this one? So these are what predefined exceptions. We have seen the list. End of error file, import error, memory error, runtime error. These are what the inbuilt exceptions are there. So here definitely uh, we have to customize our exception. We can customize, but not only customized, we can define ourselves our own exception. Okay, so that is called user defined exceptions. So predefined exception, just you have seen, it is also called inbuilt exception, automatically raised by Python virtual machine whenever a typical event occur, or we can define our own exceptions. We can define our own exceptions. That is called user defined exceptions. So, or it is also called customized or programmatic exceptions. Sometimes we have to define and raise our own exceptions explicitly to specify something going wrong, incorrect. The programmer is responsible for defining these exceptions and Python is unaware of them. See, Sometimes, as per our business requirement, as per our client's requirement, we have to assign something. Suppose age should not be less than equal to 0. For that, we may assign our user defined exception. Or salary must be negative. Okay. Or the bank account value should not be less than 1000, less than equal to 1000. Okay. And password. Suppose we are entered password. Password should be minimum 8 character. It should not be less than 8, or it should not be more than 1 to 8 characters. So in that case, we have to mention the exceptions. The password must include the uppercase. The password must include the lowercase and so on. So here, as per our requirement, we can define our own exceptions. If anyone entered age -5, it will raise the exceptions. It will raise the user defined exceptions. If the bank account value is less than 1000, okay. So in this case also, it will raise the exceptions. So how to define the exceptions? We'll see. So every exception in Python is a class that directly or indirectly extend the exception class. So whenever we define our exception, that will be the subclass of the exceptions class. So this is the syntax: class my exception. So exception class name. This is what our root class exception. This is it extend the exception class, and this is nothing but our constructor. Here you will initialize the message where you are passing the argument. That will be our message. Okay, this is what our name of the user defined exceptions, and we have to extend the exception class. Okay, so we can see here first example, my exception is name of the exception, and here we have to pass. So definitely we can raise it. Suppose we can execute it, nothing will happen. We can raise this particular exceptions. We have to use the syntax raise to invoke that particular exception, my exception. This is what name of the exception. So we can invoke is using the name of the exception, and this is what message of the exceptions. If you can execute it, it will revoke my exception, and the message is what? The academician. Okay, so three parts are there. Here is what? Every exception is the part of the exception class. This is the name of the exception, that is a class. We can revoke it using the raise. And here we can pass the message, what we want to display, if the exception will occur. Are you getting my point? So we can we can see one concrete example. So here it is what my exception is there. We can see here my exception is the name of the exception. This is what constructor is there. So here we need the message. Here we are passing the argument that will store into the message. Okay, so we need to raise the exception, my exception. Yeah, this is the message. So it will store into this particular MSG. Okay, and we can execute it. We can get the output. Here the my exception is there. It will raise the my exceptions. Name of the exception is my exception, and it is an exception. It will print the output. It is an exception. So we can put anything. We can put anything. Okay, so what you can do, you just put exception 1, here also exception 1, here it is exception 2, exception 2. We can execute it, we can get the output. Name of the exception is what? My exception 2. Are you getting? Now, another example is there. Suppose here, enter only the odd number. Suppose here a program is there, here we have to enter odd number. If you entered even number, it will raise an exception. So even exception, name of the exception. This is what our constructor. Here we input something, enter a value. And if the value is even number, it will raise even exception with some message. Otherwise, it will not raise any exception. It will print, yes, you have entered the odd value. Okay, so this is what, here we define the exception, and here we are raising the exception. Okay, so this is what our user defined exceptions. Now we can execute it. We can execute it and we can run it. So here, enter the value, say 8 or 7. It's the odd number. So yeah, you have entered the odd value. It will not raise anything. But if you execute, so 2 is the even number, 22 is even number, enter it. So this condition is true. It will raise the exception, even exception. So name of the exception is what? Even exception. And it will print the associated message. You have entered the even value. You have entered the even value. Okay. Now we can see the another example. So it's another even exception. You can see what will happen. Better to remove these things. You can see here, even exception is the name of the exception. This is here what our initialization part is there, and here it is returning the number we have passed, where we enter the value. Here inside this, we can use try and except. Inside try, we raise the exception, and the except part, we execute that particular exceptions. Are you getting this one? See this particular program. Inside try, we can raise the exception, and within the except, we use our exception name to execute it. We can execute it. So here entered, say, 55. So definitely it is a odd value, no issue is there. So it will not execute any part. It will execute, you have entered the odd value, no issue is there. Now once you have entered the even number, so this condition will be true. It will raise in the try part, and it will execute the next except part, where the name of this what? Even exception, which we have defined here. And if you have executed, you can see here, you can execute it, and a new exception is occurred for 22. Okay, a new exception is occurred for 22. So here, inside try and except, we can use our user defined exception. Okay, next is logging in Python. Okay, so a log file is maintained to store application flow and exceptional related information. Okay, application for debugging and for statistical related information. Python has a logging module to implement logging. Okay, so basically, suppose one program is executing, if any error will occur or any or the flow of the application, we need separate file we just call log.txt to store all the events, all the information. We can say this is the data about this particular program. So different types of levels of logging data, different types of log data there: critical data, error data, warning data, info data, debug data, not set data. So Python follow specific levels of logging. So for serious problem, it will raise critical error, critical message. It will save the critical information. For a serious problem, for very serious problem, we store critical. For serious problem, error, we use error inside the error. A warning message alert to the program, we use the warning. Info, for some important information, we can store as info. The message with debugging information, we can store by debug. And if nothing, if anything, if any issues there which is not part of that particular, we have to store as not set. Are you getting this one? So this is the highest level, this is the lowest level. Okay, suppose we set our log file to store warning, then it will store warning, error, and critical. It will not store regarding the info and debug and not set. Okay, so better to see the example. So here, first of all, we have to mention logging dot basic config. We have to mention the file name and we have to mention the label. Label is what? Logging dot warning. Logging dot warning means what? Warning and above. We want to store warning and above. Warning and above means what? We can store information about the warning, error, and critical, not related to this. Okay. Suppose we want to store information about any critical situation. How we can store? Logging dot critical and associated message we can store. We want to store regarding the warning. What we have to write? Logging dot warning and then message. So for critical we use logging dot critical. For error we have to write logging dot error. For info we have to write logging dot info and associated message. And all the information will store into that log file, log.txt. Are you getting my point? Now you can see the example. Here we can see there is no log file. So first of all, we have to import the logging. Okay, we have to mention the log file log.txt, and here we mention the debug. Debug means what? Debug means what? It will store all the information. Now better to not to mention debug. It will be better if you mention only the warning. That means what? It will store only these three information. It will not store about the info, debug, and not set. So you can see here it will store it will not store debug. Okay, it will not store info, debug, not set. So it will not store about the debug. It will not store about the info. It will store warning, error, critical. So this is what logging dot debug, logging dot info, logging dot error, logging dot. Suppose one critical issue will raise. So how to store that particular information? So you can store like this way: logging dot critical. Then this is the message. So you can execute it. So if you execute it, we can see the log file is there, and here we store information about this. Now we can see not only the debug, info, warning, error, critical, we can store information of the exception also. Okay, here we have to write logging dot exception, then associated message. So we can see here, we can here just first of all see the log file. Some informations are there, and try to add some more information. Say here a new request came, and here we want to store the exception error. Suppose here input of x is 7 and here we input 0. So divide by 0 will occur. So it will print, it will store this information also. Okay, we can execute it and say it is 0. So denominator must be non-zero. It will print, and you can see the log file also. Here that particular exception is also stored here. Are you getting my point? So here also suppose enter the denominator and here you put some value error. Okay, suppose here it is say O. Instead of 0, you insert O. So enter only numbers. Enter only number. It will print this particular part. So associated exception information that must be stored in the log file. So you can see the log file. You can see this one. This is another exception. Here we insert the 0, inserted 0. Are you getting here? So in the log file, we store all the activities, uneven activities of the program as well as the exceptions. Next. Python program debugging using assertions. We can use assertions also. So first of all, what is debugging? So debugging is the process of locating and correcting the bug. Already you know, logical error is nothing but our bug. So using assertion, we can identify that we can identify the error. We can identify the logical error. But before that, we should know what should be the input and what should be the output. After that, we can implement it. Note that debugging is usually done in the development and test environment, but not in the production environment. Definitely, it's very clear. So how to do this one? How to apply assertion for debugging purpose? So here, two types are there, simple and augmented. In simple, assert and condition, we put assert and then condition. In augmented, we put assert, condition and associated messages. Okay. So the syntax is very simple. Here we have to put the condition. If the condition is true, then continue the program. Okay. Else, raising errors, assertion errors, and the program will be terminated. So programmer analyze the code and can fix the problem after analyzing the assertion error. So just see the example. You can get the output. You can see the So we can see one program is there. One program is there. Increment of x. Suppose we increment. You just call the function. This is what our function. We call the function increment to. Output should be what? It is 3. So there is no problem. There is no logical error. No syntax error is there. No runtime error is there. So that no issue. So then no issue. We can get, if you execute it, we can get the output 3. Now suppose increment, see how to define. Now see the assertion part. Here the function definition is there. Here we have to mention if the input is this, output should be 3. So increment 2, output should be 3. In that case, in assertion, we should know what should be the associated output. If the expected output is appearing, then there is no problem. If expected output is not appearing, then it will print the message. The increment of 2 is 3. Okay. Now suppose the definition is what? Increment x is equal to x minus 1. So here just see the output. Here you can see assertion is raised. Assertion is there. Okay, the increment of 2 is 3. The output will, the increment of 2 is there. That means some problem is there. Okay, some problem is there. We have to check. We have to check it. Okay, so we add our assertion. If you do not add it, suppose if you do not add it, we can get no problem. We can get the output. So increment of 2 is 1. But this is a logical error. Increment of 2 is not 1. It should be 3. So to check it, we just can insert the assert. Here we put the condition. So input of 2 must be 3. And if it is true, then okay. If it is not true, then it will print the message and it will hold the output. It will hold the program. The increment 2 is 3. So once again, you can see here. Now, here in this way, we can track our logical error. But to identify the logical error, we should know the output of the associated input. Okay. So what is the difference between assertion and exception? We use assertion for debugging purpose. We use exceptions to handle runtime error. We can see the summary. So we have seen the types of errors. We have seen try and except. We have seen try and finally. We have seen raise, how to raise our user-defined exception. We discuss about assert for debugging purpose. We have seen with and as also.